Hello everyone, welcome back to the Techers. My name is Surmeet, and for this video I am going to show you how to control the brightness of your LEDs in your circuit. Okay, so it's going to be the similar circuit, but how do we control the brightness? So let's get started on that. Okay, so for this video we are doing the controlling the brightness of the LED. So to control the brightness, you might have noticed over here I've changed the circuit a little bit. Yes, I'm using only one LED to show the brightness, and I have actually connected it to a different pin rather than the digital pin 22. I am connecting it to pin number 7 because if you can see on your board, it's the PWM way. The PWM ports are on this side. So for controlling the brightness in an LED, you need the PWM ways, PWM ports. So for that, if I'm changing it to pin number 7 on our code, also we will change it to pin number 7. All right, so this is what I was talking about, it make it more readable and easily make. So for example, I had a big code last time, and if my pin number 22 was not working for some reason, and I have to change the pin from 22 to, let's say, 26. So if I didn't had this hash defined red over here, I would have to change the pin number on every places inside the code, like in my pin mode or in my loop, wherever my pin red was connected, wherever it was, and I had to do everywhere. If any part 1 is missing, if I miss out in any one place, my entire code will not work. So but if I do the hash defined red over here and give it a pin number, so any place my code is changed, and I'm using red like this, and I just have to change it over here and everything in my code gets changed. So this is a plus point of using constants like hash defined like this we have used in the code. So you've noticed I just changed over here, everything over here would be same. And for this also I'd be using I variable because I need a loop just to show you how the brightness goes. So in our our controller is 8-bit, so the values from minimum to maximum if you have to compare it with digital, which is 0 to 5 volts, so 0 to 1, it would be the values in analog, or analog values would be from 0 to 255 in 8-bit processor. I will get back in a different video about the digital communication, like how zeros and 1 actually contribute to. So 8-bit, so I'm going to show you. So 8 bits are for value 1 2 3 4 5 6 7 8, and the maximum value, if I have to go maximum value, it goes to 1 2 3 4 5 6 7 8. So 8 times 1 will be the maximum value in binary for 8-bit, which is equal to 255. And I'll show you how to read it in a different video about the digital and conversion into binary language, or hexadecimal, octal, which or all of the languages which computer actually uses all the values. All right, so for example, for getting back into here, we will go I is equal to 0, so the maximum value is 255, so we'll go less than equal to 255, and then I plus plus, and in the loop, so this time this is not a digital value, not just 0 and 1, it's an analog value. So we will go analog write red pin as value of I, and we can after, oh sorry, I missed out delay, and just to see it on a quicker response, we can only do 10 millisecond. You'll be able to see it glow brighter, and then we will, after it reaches a peak, we will make it go, or like we will make it dim. So we will go greater than equal to 0, and then we will go I minus minus. Rest of the code would stay same. Let me upload this and we can show you guys how to do the brightness. So you can see it's glowing brighter, and then dimmings to turn off. Okay, so that's basically it. You can use a potentiometer. I can show you a potentiometer. You can also use potentiometer, take its value, read its value from the potentiometer into any one of the analog pins. You can read its value. So whatever the value is, it's actually if you have to do the mapping, if you have to go over there, you just have to provide the value. Whatever you read from here, it would be divided by 4 output to the LED, because for this one, for a potentiometer, your values are in 4 times the range of your LEDs, and you can just give the output, or you can directly connect, because it's a resistor. It would limit the current based on your thing, but the only negative point is you would need to have the potentiometer in the right resistance range. So in a project, so in the other video where I'll be explaining you how to check the resistor values, you would know why we are calculating 330. So you can also go from because in the LEDs we need the current from 10 to 20 milliamps, and that's how you calculate it. So you need to have your potentiometer in that range. This potentiometer is very high in kilo ohm values, so that is why it would be so dim. The light would be so dim. It would be if you connect it directly in series for the values, you won't be able to know. So if you need to actually connect it, so this would be your terminal actually going to the series. The middle would be your output that would actually go into the ground, and then you can actually get your values. So yeah, that's how you'll be connecting it. So yeah, that's how you can connect it in series if you are just using your potentiometer in the range of like 0 to 330. So that's how you can connect it. But you'll have I can provide you another photo on the circuit where how you can actually connect the potentiometer with your Arduino to get the values for Arduino to read from your potentiometer, and then you can divide the values by 4 and provide the output to the LED, so you can actually rotate this and control the brightness. But yeah, it's the same logic. Anyways, okay, so see you guys next time.